Let me now take an example. Let us pretend that we were given this circuit without the signs assigned to the op amp. Okay. This is a circuit we already know, we have derived it. I have already told you which way the signs must be for the op amp to be in negative feedback, but we will now verify whether that is really the case. So, we will not assume anything about the signs, I will label them A and B. I need to find out whether A should be the positive terminal of the op amp or the negative terminal of the op amp. Okay. So, what is the first step? The first step is I remove the op amp, and wherever the output of the op amp was, I stimulate that, I drive it with V test. By the way, this is A and this is B, right. I also set the independent inputs to the circuit to 0. In this case, I have shown it as V I. This really means that a voltage source V I is connected that way, and I set that to 0. So, if I set V I to 0, I just short circuit this to ground. Okay. And then I find the difference V A B. Okay. Now, this is an extremely trivial circuit, right. So, if I have V test driving this point, at this point I will have a fraction of V test, which is V test divided by K. This V A B is the difference between the voltages at nodes A and B, okay. And V A, the voltage at node A is 0, the voltage at node B is V test by K. So, V A B is 0 minus V test by K, which is minus 1 by K times V test. Okay. So, clearly the proportionality constant alpha here is less than 0, and by what I described to you earlier, this means that terminal A has to be the positive terminal and terminal B has to be the negative terminal of the op amp. Okay. In other words, I have to assign the signs like that, and earlier I used those signs, we know they are correct, but this is how we know they are correct, okay, by doing this analysis. Because as you can see, this V A B, the input to the op amp, is minus 1 by K times V test. Okay. In other words, this is V D according to the assumed signs, and if I evaluated V D in terms of V naught, which is the output voltage of the op amp, and V I, what will I get? So, this voltage is V naught by K and this voltage is V I. So, V D is V I minus V naught by K, or basically minus 1 by K times V naught plus V I. Now, the part of V I that comes to V D is not relevant for analyzing whether the op amp is in negative feedback. This part is, you can see that the difference input of the op amp receives a negative multiple of its own output. Okay. So, this means that the op amp is in negative feedback. Okay. So, this shows that our algorithm works properly. I mean, in general, it is easier to remove the op amp, apply the source and analyze the rest of the circuit. In this case, the rest of the circuit was trivial, but in some cases it can be quite complicated. Okay. There is one other thing I want to point out. Sometimes it said that, hey, look, the output is here and the feedback is taken to the terminal B. We want negative feedback. So, terminal B must be negative, okay, because something is returning to terminal B. If B is negative, there is negative feedback, but such a reasoning is seriously flawed. I will show you an example soon. Now, one of the things is that there may be circuits in which both of the inputs of the op amp are in some manner connected to the output. Okay. So, in this case, terminal A is not connected to the output of the op amp at all, only terminal B is through this network, but there could be circuits where both of them are connected. This is what I showed by both terminals of the op amp could be receiving feedback from the output of the op amp. So, in that case you certainly can't use this logic, and even when only one of the terminals is receiving it, you can't say that whichever terminal the wire is coming back to is the negative terminal. A very trivial example of that I am going to show now. So, let me modify this circuit slightly. And let me insert a voltage controlled voltage source of gain -1 in feedback. I will call this V x, and this is -1 times V x. This is my circuit, and I apply my input voltage V I over here, and I take the output there. Now, let us analyze the circuit for obtaining the right signs for the op amp, so that it is in negative feedback. So, as usual, these are A and B, and this is V A B, and the first step is to apply a V test over here and also set V I to 0. So, the voltage at node A is 0 volts, the voltage at node B, let us see what it is. If I apply V test here, we have a resistive divider and the same resistors as before, K minus 1 R and R. So, at this point we get V test divided by K. Now, I have this control source with a gain of -1. So, that means that at this point I have, remember this V x is V test by K. So, at this point I have minus V test divided by K. So, the voltage V A B is nothing but 0, which is the voltage at node A, minus voltage at node B, which is negative of V test by K. So, this is plus 1 by K times V test. So, it is the same magnitude of the voltage as before, but the sign is reversed. Now, according to the algorithm I described, clearly this alpha is greater than 0, and you have to assign A to the negative terminal and B to the positive terminal. So, if I have a controlled source with a gain of -1 in feedback, where this is V x, then you certainly can't argue that, hey, look, the feedback is coming to this terminal of the op amp, it is negative. In fact, B must be positive. The correct signs for this circuit are minus and plus. So, do not use that vague reasoning that whichever terminal the wire is returning to is the negative terminal. It could be either positive or negative for the op amp to be in negative feedback. So, the method is very easy. You can analyze it systematically as I described earlier, and I also showed it with an example. So, for any circuit for which you want to determine the signs of the op amp, please use this method.